Next talk is, and I'm hoping the authors, yeah, okay, good. Repeated padding for sequential recommendation with, I believe it's Yizhou Dang is the presenter. I'm sorry if I mispronounced your name or.
Hello everyone, I'm Yizhou Dang from Northeastern University, China. I appreciate the opportunity to share our work with you. I'm here to talk about repeated padding for sequential recommendation. Let's get started. My sharing consists of 5 parts. First of all, I will briefly introduce the background of problem and method. Then I will propose our repeated padding strategy. The effectiveness of our method will be verified in the experiment, followed by the exploration of why our method works. Finally, I will summarize our work. Sequential recommendation aims to provide users with personalized suggestions based on, Sequential recommendation aims to provide users with personalized suggestions based on their historical interactions. Given the sequence of interact items, how to accurately predict the most possible item that the user will interact with at the next timestamp can be formulated as this equation. Padding is a common technique when training sequential models. The batch processing requires that the sequence in each batch have the same length. In addition, common CNN or transformer-based models can only handle fixed-length sequences. They need to initialize their model structure based on fixed sequence length. So, before training a sequential recommendation model, we usually specify a maximum sequence length n as a hyperparameter. For sequence with an original length of more than n, the most recent n items are usually chosen because they represent user recent preferences. For sequence with the original length less than n, they are padded with special value 0 to reach the length. The special value 0 contains no extra information and does not participate in module calculations. The above process can be formulated as this equation. Generally, one user corresponds to one sequence, so the total number of sequences participating in training is the number of users U. To alleviate the data sparsity problem, data augmentation is often used to augment the original data to increase the number of sequences involved in model training. It makes linear but appropriate changes to the original sequence to generate a new sequence. Both original and augmented sequences are involved in training. For example, we insert a similar item 4 before items 7 and 9 and generate a new sequence 1, 7, 4, 9. In each epoch, each sequence will be augmented at least once. So the total number of sequences involved in model training will be at least 2U. As we can see from this figure, if we follow the most common settings and set the maximum sequence length for the beauty dataset to 50, the horizontal axis is the user, the vertical axis is the length of their sequence, and the red line represents 50. A large number of sequences need to be padded to the length of 50. All the white space below the red line can be considered as the idle input space. Also, due to the data sparsity in recommender systems, majority of users have short sequences. The above common sense padding strategy and idle input space lead us to a problem that never has been explored before. Can we utilize this idle input space by padding other content to improve the model performance and training efficiency? Here, we present our repeated padding method for sequential recommendation. Specifically, we utilize the original sequence as the padding content instead of the special value 0. Given the original sequence 1, 2, 3, 4, we pad the original sequence once as the left and get the padded sequence 1, 2, 3, 4, 1, 2, 3, 4. This operation can be repeated multiple times. We use M to represent the number of times padding is executed. Here, M can be specified in advance or calculated. For example, if n is equal to 10, sequence 1, 2, 3, 4 can only be padded once, and sequence 3, 7, 9 can be padded twice. However, there is a problem with the above padding strategy. There may be cases where the end of original sequence is used to predict the head. For example, there will be cases where 1, 2, 3, 4 is used to predict 1. To solve this problem, we add the special value between each repeated padding. We also provide methods for selecting the value of M, including fixed value, maximum value, random selection between 0 and maximum value, or random selection between 1 and maximum value. Compared with the existing methods, our method has the following advantages. Our method does not increase the total number of sequences involved in training, where previous methods can be considered as extending the length of dataset vertically. Our approach utilizes the free space horizontally. Our method does not contain any hyperparameters. Also, our method does not contain any learnable parameters. It does not require a training process. It is a model-agnostic plug-and-play data augmentation method. Our method has a potential drawback. Intuitively, it is more effective on short sequence dataset and may be ineffective on long sequence datasets. This is because for long sequence datasets, most users have the sequence length that close or exceeds the given maximum sequence length, and thus there will be no space left for padding. We will verify our conjecture in the experimental section. Our experiments use 5 short sequence datasets and 1 long sequence dataset. Baseline includes 3 categories. The first category is used to evaluate whether repeat pad is effective in improving the model performance. The second category is widely used heuristic data augmentation methods, which do not require training but include several hyperparameters. The third category is representative of training-required data augmentation methods. As shown in the tables, after adding our repeat pad to the original model, the performance of all models is significantly improved. These results verify the effectiveness of our method on short sequence datasets. It can be applied to various types of sequential models. When we use repeat pad on long sequence dataset, the performance is not satisfactory. Repeat pad can only achieve less improvements on some methods for long sequence dataset and even cause performance degradation on some methods. Most user sequences do not have enough space left for repeated padding. Compared with existing data augmentation methods, repeat pad achieve competitive performance. We can also observe that some random data augmentation methods can even lead to a decrease in recommendation accuracy. These methods may introduce too much noise that destroys the integrity of original sequence. In an application study, we explore the setting of padding frequency M and whether a delimiter 0 is need to be added. Our conclusion is that the model performs best when M is randomly selected between 1 and the maximum number of times. Whether to add the delimiter 0 depends on the type of a model. To explore the reason for the effectiveness of repeat pad, we visualize the loss curves of different methods and provide their training efficiency. We can observe that repeat pad's loss converge is slightly faster than the original model. Meanwhile, our method significantly improves the recommendation performance while only adding a small amount of extra time. Researchers have shown that the more stable or smooth gradients are more helpful for model training. We illustrate the average gradient of item embeddings throughout the training process, with and without our repeat pad. The average gradient values are more centralized with the addition of our method. Smooth updating the gradient allows the loss converge stably and improve the model performance. We believe that repeat pad can make the gradient updates more stable. It enhances the short sequence in an almost lossless way and makes the model focus more fairly on long and short sequences. At the same time, we also suspect that it has some kind of regularization effect, making the data distribution more uniform. In this work, we start from the commonly used padding strategy, aiming to utilize the idle input space to further improve the model performance and the training efficiency. Based on this idea, we propose repeat pad, which leverages the original sequence as a padding content instead of the special value 0. Our method does not contain any parameters and training process, and it is a data augmentation plugin with high applicability. Extensive experiments demonstrate the effectiveness of our repeated pad. We also provide multiple perspectives and insights into what makes our methods effective. For future work, we hope to provide theoretical analysis for repeated pad. There are also some discoveries in the field of large language models that are similar to the repeated pad. We also plan to explore the augmentation of medium-long sequences and the use of delimiter 0. That's all. Thanks for your time.
Thanks for the talk. There's several questions. Before I jump to those, I want to just ask one myself. Can you explain a little bit about the 0 delimiter you're using and if there's anything special about that? Because if you're repeating the sequence, you might be putting kind of the output you're trying to predict ahead of that delimiter. So is that handled in a special way?
Yes, let me get that slider. Yes, if we pad in the sequence in the left of the original sequence, there will be a case. For example, the 1, 2, 3, 4 is used to predict the item 1, 2, 3, 4 is the input, and the predict y is the item 1. So we hope to prevent this from happening. So we add the special value 0 between each repeated padding. But actually, in our experiments, we found that this special value 0 can't prevent this happening. We call this the laggage of feature information, because in autoaggressive models, if we just add the special value 0 between each repeated padding, the future information will be still laggaged. So this is an interesting direction for future research.
Okay, let's see. In terms of those questions, did you try your method on any real sequential data sets that are not just review or rating based?
Sorry?
The question is, did you try it on any data sets that have like real sequential user behavior patterns?
Sorry, we don't have tried any other data sets yet. Maybe in the future we can deploy this method in the industrial scenarios and test if it's effective.
And another question is, did you look at how the impact of the method is for like short versus long sequences?
Sorry, Yes, we have do some experiments to explore the impact of our method on short and long sequences and long sequence data sets, but the experimental results are not included in this PowerPoint. Maybe you can send me an email we can communicate about these experiments. Thank you.
I'll take one more question. Will the padding reinforce recent signals and therefore bias towards recent user item interactions?
Sorry, I can't hear very clearly.
Yeah, I know it's hard up here.
Yes, we think that the repeated padding may make the model focus fairly on long and short sequences and emphasize the recent interactions, because in the traditional padding strategy, the long sequence may get more attention when model training, when we do in model training.
Thanks. All right, let's thank our speaker again.
Okay, thank you. Thank you for your time.